Welcome to our webinar titled The Importance of Infrastructure in the Support of AI, ML, or Artificial Intelligence Machine Learning Applications. My name is Joe Fleischer. I'm with MLConf, and I'm thrilled to be moderating our webinar today. I just want to note before we begin, we invite you to respond to polling questions we will intersperse throughout our webinar. Now, it is my pleasure to introduce our distinguished guests, and our distinguished guests are, first of all, Bill Wright, Head of AI, ML, and Intelligent Edge for Global Verticals and Accounts with Red Hat, Martin Isaksson, CEO and co-founder with PerceptiLabs, his colleague, Robert Lundberg, CTO and co-founder with PerceptiLabs, and Václav Pavlin, architect with the Office of the CTO with Red Hat. Just a few things I should point out. Throughout the course of our webinar, we will be hearing from Bill and Václav, and then Martin. We will see a brief demo, by the way, featuring Robert. We'll set aside some time for discussion with our distinguished guests, and then we'll also set aside some time to address your questions, and we will intersperse polling questions. At this stage, it is now my pleasure to turn the floor over to our distinguished guests, Bill and Václav of Red Hat. Please give a warm welcome.
Hey, thank you, Joe. I really appreciate it, and I'm really honored and kind of humbled to be here today because I'm surrounded by some really talented leaders in artificial intelligence, and that's all the other guests that are on the line today. One of the things that people don't realize about Red Hat is generally they think of us as software infrastructure, but we actually have quite a few projects in support of artificial intelligence and a few interesting initiatives from that perspective. And we've also looked to build purpose-built platforms that support artificial intelligence applications as well, creating, I guess, if you will, an ecosphere for them to live and thrive, basically providing all the data that they require to function effectively. And so what I'd like to do is have Václav talk a bit today about the Open Data Hub and also explain a bit about the infrastructure aspect as well and what that relevance is to artificial intelligence. And I think you'll probably learn a few new things, as will I, and hopefully you'll enjoy the session today. So just thank you for participating. And Václav, go ahead and take it away.
Thank you, Bill. Hello, everyone. As been said, my name is Václav Pavlin, or Václav Pavlin. I work for Red Hat, as you've heard, part of AI Center of Excellence in the Office of the CTO. And what I would like to talk about is why Red Hat is a good vendor or provider of what we do with regards to AI targeted infrastructure. Let me see if I can advance the slides. So first of all, to set the context, I would like to tell you something about how Red Hat sees AI. And we have, in general, came up with these 5 sections, 5 pillars. So you can see that data as the foundation is there, as the base for all of them. And it's kind of obvious data is the new oil or new gold or whatever you want to call it. So we are pretty heavily invested in storage systems and in managing the data, and we see the importance of that. The next pillar, and one of the main pillars, is AI as a workload. So Red Hat generally provides platforms, and be that operating system or virtualization technologies or containerization technologies and systems like OpenShift, right? And with that, we need to make sure that AI runs well on those systems. And I'll talk more about it later. What does it mean? But basically making sure that our customers can run some AI workloads on our software. The second pillar is about software development. And for us, that's mainly open source software development, obviously. And we want to make sure that AI accelerates that and that it allows developers to be more efficient, that it helps them, that there are services and solutions for developers to speed up the development and to be more productive and more have their software more stable and more performant. The third pillar then is our products and services and how AI can help them to enhance and to make them more intelligent, right? So the goal for us to build an intelligent platform. So I've said that one of the goals is AI as a workload on our platforms. So those platforms should be enhanced and should be intelligent based on AI. And also our services like Red Hat Insights, which help our customers to run their clusters and their workloads, to give them some insight on how that stuff works and how performant it is, where there are any issues. So those are other spaces where we can leverage AI. And then obviously enable our customers. So that kind of goes back to the first pillar, but it scales much wider. So if you think about the customer or the user can run AI as a workload, it also needs some supporting and supporting apps and services that they can deploy from various vendors and various partners that we have. So we want to make sure that all our broad partner ecosystem partners, vendors can deploy on our platforms and can help our customers to build those intelligence applications. So basically what it means, if you look at where most of our applications run, there is this stack, right? If you think about the conference platform that we are all connected to, there is probably some bare metal, some hardware machine somewhere in the data center that has some CPUs, some memory, maybe not GPUs, maybe it does have GPUs, I'm not sure. Then there may be some virtualization layer, which allows it to leverage better the resources. And maybe there is no virtualization layer. There definitely is some operating system, which in my case would be probably RHEL. And then there is some platform that is making the runtime and deployment easier and the management of the applications and services easier. So for me, that would be Kubernetes or OpenShift. And then there are those services that allow us to actually use the platform, right? So some APIs, some UI, all these things. And the main goal of us as Red Hat is for those services, which is what our users and customers would write and deploy and build. For data scientists, that might be some models or some APIs-based models. Some model-based APIs. These services, they need to reach to those resources. And that's the main goal for us. We need to make sure that the whole stack, all those layers are integrated well enough so that if my service requires GPU, the hardware can recognize that there is a GPU card, the virtualization can get the GPU passed through itself, the operating system has enough, has all the kernel drivers for that, the containerization platform or container platform has all the means and tools that it can provide a GPU to a specific container, and then the service can actually leverage, has all the other frameworks and libraries that it can leverage that GPU. So that's our goal at Red Hat, to provide that whole stack, to be able to go and make it easy for customers to focus on those services rather than on enabling access to those resources. I throw around words like OpenShift and Kubernetes, so I will speak briefly about the relationship between these. Probably many of you heard or realized Kubernetes probably won the competition to be the way how applications are now run in major clouds with containers, and it's a container engine that is able to run your applications where you can orchestrate them and manage their lifecycle. What happens if Kubernetes meets the enterprise, which means it has to be production ready, it has to be scalable, it has to be manageable. There are other things that are not integral part of the Kubernetes, and that's where OpenShift comes in and builds around Kubernetes and builds on top of Kubernetes and adds those powers that we believe are make it the enterprise-grade platform. So things like logging of your applications and of the whole platform. Same for metrics. You need to be able to watch what your application is doing and react to when it's starting producing some weird metrics. You need to be able to build pipelines for building your applications, but also building models and managing the data. You need to be able to authenticate with the enterprise-grade authentication. You need support and upgrades for your platform. So that's where OpenShift adds to Kubernetes and also feeds the new features and bug fixes back to Kubernetes as well. With that, as part of OpenShift and a part of Kubernetes, there is new paradigm. It is not completely new, but it's now gaining more and more popularity, and that's the operator paradigm, basically. So encoding the human knowledge about how to run applications into a software so that it can automatically deploy, undeploy, update, fix some issues in the running software, in the deployed application. And around this idea, OperatorHub.io was built, which is basically kind of a hub for those operators. You can see I screenshotted here categories AI, ML, and big data. There is a bunch of operators that allow you to deploy various applications like Spark or Seldon on top of Kubernetes and OpenShift. What we do at Red Hat as well is working with our partners and ecosystem partners and ISVs to broaden this selection of operators, and then also making sure that these operators are certified and verified and tested on top of OpenShift. So when you as a user come to OpenShift to the catalog and you click on AI ML category, you get all these, and we can make sure that all of those work on that specific version of OpenShift that you are using. And you can see a bunch of interesting names like NVIDIA or H2O, but you can also see PerceptiLabs there. So PerceptiLabs is our dear partner who also contributed an operator to our catalog, and we help them to go through certification and developing the operator and helping them to take their knowledge about their application and encode it into the software of the operator. So I've mentioned that I'm working on the project Open Data Hub, and that project is basically, the goal of that project is basically to provide an end-to-end AI/ML pipeline or process of workflow or lifecycle management on top of OpenShift, right? So we're looking at the whole lifecycle management of models and data and whatever is needed to do AI, ML, and data science. So you have a section where you acquire your data and you do some data preparation. And we use Ceph object storage, and then we pass the data to Spark and Jupyter, or make it available in Spark or Jupyter. We can train models with TensorFlow. We can work with the models with experiment tracking and metadata using some of the Kubeflow services, for example. And then we can pass the model further in the lifecycle and deploy it via tools like Seldon, or directly with like Flask application wrapper into the OpenShift. And then obviously you need to monitor your data. You need to monitor your models and make sure that it doesn't drift or skew, or it generally doesn't start behaving weird and unexpectedly, right? So you need to be able to monitor that. And we are trying to build that into a cohesive end-to-end platform, which you can easily deploy on OpenShift. There is an operator for that, and I'll talk about that in the next slide, basically. So Open Data Hub, if you go to OpenDataHub.io, you can take a look at what we have. And basically, we took that operator paradigm and put it one abstraction level above that, basically, and we are trying to build a meta operator. So operator in general manages lifecycle one application. So we are trying to manage lifecycle of some operators so that we can give you the integrated platform with a bunch of services that are useful for your general machine learning work. So what Open Data Hub is not, it is not a product, it is not a supported solution. What it is a reference architecture, and it is a community project. It's an open source project. How we see that is that it's a blueprint for building this AI as a service platform on OpenShift. So you can take it as it is, and you can just run it and use it, or you can just rip it apart and put in new services and remove those that are there, and do whatever you need with that. But at the same time, it's not just some POC project that we would just put together as an experiment. It is a production-ready service that is running internally at Red Hat in our own data center on our own instance of OpenShift. And many teams are using that. A lot of data is flowing in from various systems like build systems, CI system, customer data. And a lot of teams are successfully using that to get some business value and some knowledge out of the data. The services that are currently available through Open Data Hub, and plus all of the Kubeflow services, I'll just take Apache Airflow here as an example. We have added it very recently. There were many requests for that, and especially there was a request from our internal team that is heavily using our internal instance of Data Hub. And they are also using Apache Airflow, and they didn't want to maintain that on completely different systems. So we worked with them and added the Apache Airflow there. So if you are interested in Open Data Hub, you want to try it, maybe you want to contribute, we are always open to some feedback. I mentioned Kubeflow and Open Data Hub a lot, so I want to bring that relationship here as well. So we have been asked many times before for like, are we competing with Kubeflow or what is the relationship? So for some time it wasn't entirely clear, and then a couple of versions ago we decided to completely drop what we had and start over on top of Kubeflow. So right now we are leveraging recently added Kubeflow operator and adding some features that are key for Open Data Hub, but mainly using the Kubeflow operator. And we are using Kubeflow manifests, which are the deployment manifests for Kubeflow as part of Open Data Hub as well. And then we add whatever we need. So similar relationship as with Kubernetes and OpenShift. And then obviously at the end, we feed back to Kubeflow whatever bug fixes that we come up with or features that we would like to see in Kubeflow. And our goal is also to contribute some of the components that we have, because wherever we believe that the use case is common across the whole AI ML community. And we believe the Kubeflow is very good for AI ML community because there is plenty of people interested, and the community base is pretty wide. As I mentioned, we have Open Data Hub deployed internally, right? So I wanted to bring back this slide for how Red Hat sees AI and what we actually do with AI internally in our internal data hub, and how we leverage that platform that we are building. So we work on telemetry analysis, and that's the workload, right? We are building models to predict some things on top of metrics, let's say. So customer is running a cluster. That cluster is sending back home some telemetry, and we run analysis on top of that so that we can tell the customer, hey, Mr. Customer, there is potentially an issue with your disk storage, or there is an issue with upgrade or something like that. Then for the development, there is a project, it's also on GitHub, Thought Station, THOTH, where the team is building a system that analyzes software stacks. So let's say I'm building an application that leverages TensorFlow and a bunch of other dependencies, and I can send that software stack to this API or to this service and add some description or context, like I am building this on top of RHEL. I'm running on OpenShift 4, and I will be using GPU, this specific version of GPU, and I have this storage system. And they are able to give me recommendation for the best versions of my dependencies, of the TensorFlow and other dependencies, so that my stack is the most performant and most secure that I can get. We are enhancing the products, as I mentioned, with the idea, the general end goal is self-driving platforms. So I mentioned that we provide platforms as Red Hat. And we want to make sure that the platform is not hard to maintain, and for it to be as easy as possible to maintain it. Ideally, there would be no maintenance, and the platform would be self-driving. It would fix itself. It would self-upgrade or automatically upgrade. It would notify before something happens. So that's the goal, and we are working on that with our customers to get to those self-driving platforms. And then for the enabling the customers, I've already mentioned that, and I'm coming back to it because it's super important, especially as we have PerceptiLabs here on the call as well. Ecosystem enablement. So we're working with many companies that are popular and successful in the space, and we are helping them to get on top of OpenShift so that and to get into the operator hub so that their software is readily available for our users and customers. And then down there, again, data as a foundation. We have a Ceph-based data lake internally, and that's basically what's supporting all of these initiatives, where all the data are flowing and where we manage all our data, either from the customers or internal systems, where we can then build all these AI-related projects. That's basically it from me. And I would like to thank you for attention. If you are interested in more information, definitely visit opendatahub.io. You can also go directly to our GitHub organization, opendatahub-io. And if you're interested in AI/ML on OpenShift in general, then there is this URL. So with that, thank you again, and it's really an honor to be part of this webinar.
Before we hear from Martin and his colleague Robert, I want to pose our first of 3 polling questions. We're going to pose this quickly, then I'll turn the floor over to Martin of PerceptiLabs. Our first of 3 polling questions, which we'll pose quickly, ask attendees to indicate the extent to which you agree with the following statement, that your organization currently has the infrastructure to sustain the ongoing development of machine learning models. What I would now like to do is turn the floor over to Martin Isaksson. Martin Isaksson, who is CEO and co-founder of PerceptiLabs. Please give a warm welcome to Martin. Thank you very much.
Thank you. Hi, everyone. I'm Martin Isaksson, and I'm CEO and co-founder of PerceptiLabs. PerceptiLabs is a globally operated machine learning startup, and we have created a new visual way to build advanced machine learning models in order to make it easier and more intuitive to work with. And at the core of PerceptiLabs is a unique visual modeling tool that allows data scientists and machine learning engineers, in other words, our users, to quickly build out and interpret models using an intuitive GUI. And this modeling tool is at the core of the PerceptiLabs platform. And this enables multiple useful features for the users. For example, they can work in teams, iterate and prototype through different model types, and keep track of all of these experiments. And this platform runs on OpenShift, which allows users to focus only on creating the models and improving them, and not have to care about the infrastructure and scalability. And today I will cover several parts that data scientists and machine learning engineers and enterprises encounter while working with machine learning. I will also explain how PerceptiLabs solve these problems and actually show you the value that PerceptiLabs brings to the table along with Red Hat and OpenShift. Then Robert, my co-founder and CTO of PerceptiLabs, will show a demo where we will build a generative model, or GAN. And we will show you how intuitive and easy it is to use PerceptiLabs. See if I can switch slide here. So when enterprises begin to work with AI and machine learning, the first problem they encounter is the complexity and high costs of setting up a fully functional workflow or pipeline. And they see how hard it is for the data scientists and developers to understand the models and the models' predictions. And on top of that, it's difficult for teams to keep track of all experiments and understanding who is responsible for certain changes in the models over time. So when working with machine learning at enterprises, we need to think about the infrastructure. We need to set up an efficient workflow, just as with software development, where we set up a DevOps system. We need something similar for machine learning. And a common term these days is MLOps. So there are several parts of this workflow. There's data management, which is the data layer, responsible of preparing the data and acquiring the data. And then there's the model management and building the models, which does exactly that. And then there's the serving management, where we keep track of how the models live in production, monitoring them, and make sure that everything runs as it should. And all of this has to run on a secure infrastructure, which scales well and utilizes the hardware and resources that are available. So with Red Hat and OpenShift, users can use different Red Hat partners that cover these three different areas of the machine learning workflow. PerceptiLabs is covering the model management for building and training models. And OpenShift takes care of the whole underlying machinery, making sure that users can run on a secure, scalable infrastructure, which is one of the big things to solve here. And we see the model management part as the most complex one and the least transparent part of the machine learning workflow. We also see that it's the central hub that glues the whole workflow together. And PerceptiLabs focus on exactly this, on reducing the risk and compressing the time to value so that our users can get production-ready models faster. So to dig into details, we're providing a drag and drop GUI to faster prototype and iterate through different model architectures. And we have a lot of visualization, so users can understand how the model works, explain the predictions, and communicate results back to the rest of the team. And it's very important when users experiment and try to get optimized models ready for production that they have a platform to keep track of the iterations and progress in one central hub. So the goal of PerceptiLabs platform is to create an environment for data scientists where they focus solely on the core important work, on building models. So we take care of everything around it. We remove the need to worry about the code and bugs, and we provide them with great debugging tools and visualizations for every single underlying variable so that they can improve their models and the outcomes. We empower them to communicate with each other and share the results in order to collaborate, which is very important as well. So let's look how data scientists and machine learning engineers build their models today. And there are actually a very few choices. So one is to build a model with code or frameworks such as TensorFlow, Keras, PyTorch, or scikit-learn. Or the other one is using AutoML. Both approaches has their pros and cons. Just working in code gives you a lot of flexibility, but it's much more complex and it takes longer time. Users have to create boilerplate code for visualizations, and they need to make sure that everyone is running on the same versions of the frameworks. AutoML has its restrictions. It's basically a black box, and it's not easy to understand how the model got to its results. And it only works for a few machine learning techniques. For example, if you want to use reinforcement learning, there are not that many AutoML algorithms supporting that. And then there's a PerceptiLabs. You can see it as a layer on top of the code APIs and frameworks, just making them more efficient and streamlined and easier to work with. So PerceptiLabs keeps the flexibility of the code APIs, as well as give a degree of automation to the user, while making the process of building models transparent and intuitive. So PerceptiLabs enables fast modeling with our visual modeling tool. It's a drag and drop tool that allows users to build out different models. It can be seen as a GUI for TensorFlow, for example. Users get instant feedback of the output in each component, which is great for debugging. And it's an automatic input-output shape fitting, which means users can move faster in prototyping and build out optimized models. And with some more advanced visualizations, users can visualize every single underlying variable in the model that's being run. In other words, turn the model inside out, more or less. And we really take a high-level abstraction of what's really complex here, but the users can choose to go into low-level code and reprogram what's going on behind the scenes. In other words, we keep it flexible and transparent. And also, we keep it flexible by making it possible to work in code and with our visual modeling tool, all in the same platform. So our users can run on their custom environment, as an example. We provide them with a few dependencies, like TensorFlow for now, but it's very easy to decide which frameworks to run on. So in other words, it's customizable. And by having it data flow driven, we keep the same flexibility as if users are working with code. We also empower our users to build models in notebooks if they prefer that instead of or in addition to our visual modeling tool. So to keep it flexible, we also made sure that they can toggle between the GUI and Jupyter notebooks, since it's a very popular way of working with machine learning models today. And I already mentioned this several times, but I want to highlight it again because for me, it's very important. So it's essential to have one central hub for everything. So users can have an overview of all the experiments going on, who is responsible for what changes, and that you can reproduce different experiments that you've done earlier. For example, if someone has built a model and then 6 months later, another user tries to figure out who did the changes and who's responsible for maintaining the model. In other words, tagging the model to someone. It is tricky if there is no opportunity to gather everything in one structured and organized place. So having a central hub also allows to have an admin who can approve if something should go out to production or not. In other words, a central hub is a great way to foster collaboration and productivity. So now it's time for a demo where Robert Lundberg, the CTO and co-founder of PerceptiLabs, he will build a generative model using PerceptiLabs visual modeling tool.
Well, thank you very much, Martin. And I'm going to ask our distinguished guest to go on mute. Attendees, listen carefully. You may want to turn up your volume just a little bit. And as Martin mentioned, his colleague, Robert Lundberg, CTO of PerceptiLabs and co-founder of PerceptiLabs, is going to show a demo. And that will begin now.
Hi, I'm Robert. and this is a demo of PerceptiLabs modeling tool. In this demo, I'll be showing you how to create a generative adversarial network. In here, you can keep track of all your different models. You can see their different statuses, where and if they've been exported, the training time of the models, who's been working on it, and when they were last updated. To create a new model, all you need to do is to go over here, and then you can select from one of the predefined templates. In this case, as I'll be building again from scratch, I'll be using an empty template. As soon as you create a new model, you'll get put into this workspace, where you can use components to define your model. These components are split up into different categories that you can see up to the top left. We have the data components, the processing components, deep learning components, mathematic components, training components, and finally a custom component, which you can use if you want to completely customize a component from scratch. For this scan, I'm going to train it on handwritten digits, or more specifically, the MNIST dataset. However, to start out, I'll be building the generated part of the model. And this generated part is what's going to produce images which look as closely to the MNIST images as they can. To start that part, I'll be dragging out a random noise generator. This one will act as input to the generator, and it will be what the generator bases its output on. I'll set the output shape of it, and as soon as I press apply, you'll see a preview pop up. This is so, as you're building out your model, you can get an understanding of what each component does and what they output. Also notice that on top of the component, you see a little number. This is the dimension of the output of the component. And this is great for keeping track of the architecture as you're building it, or if you're importing someone else's model, just to see overall what it does and how it is structured. For the generator part, I'm going to build a fairly simple 2-layer deep neural network. And I'll be using fully connected components for that. The first one I'll set to 128 output neurons, and I'll set an activation function to it. Notice also how each component has a set of settings. These settings are essentially as templates for generating code. The generated code you can always see by pressing the Code tab. Not only does this give you full transparency of what actually happens in a component and how they function, but it also allows you to custom edit them in case you want to add some functionality or remove something. Then I'll add the second fully connected component. I'll set an output of 784. The last thing I'm going to do for the generator part is to add a reshape component. This will make sure that anything that comes out of the generator part will be seen as an image rather than just an array like it was from the last fully connected. After I have the generated part done, I'm going to add the real data, which is going to be trained against. To add real data to the model, I'll simply just drag out the data component and select whichever data I want to use. This data is flattened, which means that we need to reshape it just like we did with the generated data. And then we'll get our image. Now that we have the generated part and the real part, I'll add a switch component. This component will let us switch between the two inputs and select only one of them as an output. I will go every other, so it will start with the generated data, then the real data, back to generated data, and so on. And this is because the discriminator part, which we'll be building after this, is going to train to distinguish if the data it sees is real or not. Here I just need to select which data we're going to start with as an output. And now I can build the discriminator part. And more on the discriminator part is that the reason it's trying to distinguish if the data is real or not is so that it can almost act in a battle against the generated part. And that's where the adversarial part in GAN comes from. The two parts of the network it is trying to balance and become better and better. So the generated part is trying to keep generating more and more realistic data, while the discriminator part is trying to figure out which data is real or not, and gets better and better as it goes. For the discriminator part, I'll add another fully connected component. I'll set it to 128 neurons, just like with the generated part. And then finally, I'll add a single output component. Fully connected component, but it will act as an output of the model, where I only set the neurons to 1 and no activation function. The purpose of this one is that it's supposed to be a 1 in case the discriminator thinks the image is real, and a 0 if it thinks it's false. Now the model is technically done. The only thing we need to do is to add a training component. Now this training component does a few amount of things. It takes all the other components and executes them in the right order. It runs the training loop. It provides a bunch of visualizations. But most importantly, this component is the reason why we can create a GAN with the same complexity, or just about the same complexity, as we can create an image classification model, or a regression model, or reinforcement learning model, etc. The training component has a few settings as well. We need to set which component is the switch one. We need to select which data is the real data. I'm going to lower the epochs a little bit, and we can increase the batch size just to make it run a bit faster. Now the model is ready to start running. So let's press the run button and then start the training. This will cause it to start initializing and preparing everything, but as soon as that is done, we'll get thrown into a statistic window where you can see an overview of how the model is progressing. Up here you have the broad overview over what's happening, so you can see things like the generator loss, discriminator loss. You can see the samples, and these are the generated samples, or samples of the generated output and the real output. You can also view the data distribution of the real data and the generated data. And the goal here is to make this become as similar as possible. In the bottom right, you see something which we call the view box. You can control the content of the view box by clicking around on the map. And this lets you peek into each and every component inside of your model and see exactly what's going on inside of it. So you can see things such as the output, the weights and biases, or the gradients. We found this to be a great way to not only get an understanding of what's going on inside of the model during training, but also excellent to find errors or bugs during training. An example of this is, say that the gradients would explode or flatten out. This would be a great indicator that something is not running as it should inside your model, and you can then stop the training, take a step back, and figure out what's going on. As soon as the training is done, we'll be able to go into a statistic view, where we can, sample by sample, see exactly how well our model performed. This statistic view also, this test view also have a map at the bottom. This map, just like in the statistics view, is clickable. And the purpose of it is that you can go through your model and see what exactly happened for each different sample. Then you can go forward sample by sample and see how everything looked like. In this case, this is the input which generated this sample, and you can that way kind of figure out how exactly things are being generated and happening. That was everything for this demo. I hope it gave you a good overview of how you can use PerceptiLabs. If you want to try it out, we have a free version, very easy to download. The instructions are on our website, PerceptiLabs.com. We are constantly updating this tool, and any feedback you have would be very much appreciated. Thank you very much for watching.
Well, thank you very much, Robert. Before we launch into a discussion, we want to pose our second of 3 polling questions. We want attendees to indicate the extent to which you agree with the statement that your organization currently has the tools and knowledge that are necessary to sustain the ongoing development of machine learning models. Our previous polling question asked about infrastructure. This question asks about tools and knowledge. What I'd like to do now is launch into our discussion and pose our first question to you, Martin, regarding TensorFlow. The term TensorFlow has come up a few times during this webinar. Martin, what are your thoughts regarding TensorFlow as it relates to what we've been discussing?
Great question. I'm going to take in Robert on this one as well. So TensorFlow, it's been around for a long time, and they really figured out well on the back-end side, so to speak. And the UX, of course, is improving a lot. I mean, back in 2016, when TensorFlow was still in beta, they have really improved, considering, I think, the competition between PyTorch and TensorFlow as well has contributed to giving a better UX. But we see that it can be made more efficient. And with machine learning, and especially deep learning, a visual interface fits pretty well, since a machine learning model is really a graph, and you can pass the data with different, in this case with PerceptiLabs, arrows or connections. So it makes it very intuitive, in our opinion. I don't know if you have something you want to add there, Robert.
Yeah, not surprising, I agree with you. I can also highlight that we mentioned TensorFlow a lot, and we're currently using TensorFlow as the backend for PerceptiLabs, where PerceptiLabs kind of is a UI for TensorFlow. And the reason we're going with TensorFlow over, say, PyTorch at the moment is most of the companies we talk with, first of all, are working with TensorFlow, and second of all, probably the reason why they're working with it is that TensorFlow still has a bit of a leg up on the production and deployment into production. So that's, yeah. That being said, we're not just staying TensorFlow forever, or we don't have thoughts of that yet, at least. Since we are a UI or an interface on top of a framework, we're also looking to implement things like PyTorch or maybe even scikit-learn later down the line.
Well, thank you very much, Robert and Martin. This raises a follow-up question. We talked earlier, certainly, Václav talked about earlier about the importance of infrastructure, and I want to hear your thoughts, returning to you, Robert, regarding the importance and perhaps advantages of maintaining a large-scale, unified artificial intelligence or machine learning infrastructure, particularly regarding the work that PerceptiLabs does.
Yeah, so I can start with talking a fair amount about how Open Data Hub and PerceptiLabs work together in that manner, since we are doing a project currently. And how it works is Open Data Hub kind of, as was described earlier, kind of gathers all different pieces and puts them into a workflow to create this MLOps pipeline for you. PerceptiLabs place in that makes it, or how it fits in rather, makes sure that the developer or the machine learning developer can sit and focus only on developing machine learning models. And how it ties together is that the data part and the serving part, since Open Data Hub already handles all of that and kind of glues it together, PerceptiLabs can just fetch whatever data is available, expose it to the developer, and they can then do pre-processing on it. They can build their models with it, and then they can simply export the models straight out of the tool, and it will go, thanks to Open Data Hub, through a little pipeline and then straight up into serving. So the advantage there with the entire pipeline is that everyone can sit and focus on what they need to do, and it still just works.
Martin, what would you add?
No, I agree with what Robert said as well. And I think it's very important to understand that the infrastructure, I mean, if you work in academia or doing some research where you're just trying to hit the high accuracy of a model, you don't really have to think that much about infrastructure. But as soon as you jump into an enterprise environment, you need to think about what it takes to do it in a production environment. There's a lot of things to think about, and that's what's being solved, or at least making a lot easier by, as an example, using OpenShift, Open Data Hub, PerceptiLabs, Seldon, and other parts. It's trying to just make it flow as easy as possible.
Thank you, Martin, and Robert before him. I want to hear your thoughts. Martin, I'll return to you now. We talked earlier about OpenShift. I know Bill and Václav both talked about OpenShift. I want to hear your perspective. I think attendees would as well, in terms of PerceptiLabs' work with OpenShift from Red Hat.
So, if I understand the question correctly, is how the value we bring together with OpenShift and PerceptiLabs?
Exactly.
Okay, thank you. Yeah, and this is exactly what I just think I just touched on a little bit. Our goal is that our end users can just focus on building the models. And with that, I mean, the first thing, which is the infrastructure that this is all about, that's a very heavy piece, and we highly recommend something to use for that. For example, OpenShift and what Red Hat provides. And then it comes to building more complex models or advanced models, like if I want to build a reinforcement learning model, there's a lot of think about that there as well, and you need to have skills as a programmer. For example, think about how I thread everything and run things in parallel processes. And that's the thing that PerceptiLabs want to help with as well, so that you as a machine learning developer just sit on top of everything and just focus on the models, because that's difficult enough, just that piece. So that's what we think we can bring together to the table.
Thank you very much. I know before we hear from Bill, there's some aspects of this discussion we want to cover. Just briefly, before we hear from Bill, Martin, I wanted to follow up about other components. We've certainly talked about TensorFlow. I thought I heard you mention Seldon as well. So before we hear from Bill, briefly, Martin, is there anything you would add regarding other components required for this framework, such as Seldon, for example?
No, I think I'm mentioning seldom because I think they're doing a great job. And it's what Václav talked about earlier of the different parts in, for example, Open Data Hub. So we have different vendors like PerceptiLabs, Seldon, H2O, etc. that the users themselves can just choose what they want to work with. They can pick everything. They can go with the full solution or handpick what they like to work with. And what PerceptiLabs does is make sure that you develop your models, you keep track of everything in one environment, and then you can easily export the model for your production environment. And then there's a question like, what does this production environment look like? And it can be a very easy one using Flask or some TensorFlow server, or it can be more advanced, I would say, one like Seldon that's made a very sophisticated solution on how you can deploy your models in production and keep track of maintaining basically the models there and just make sure that nothing really odd happening. For example, training serving skew is one term that's very common, and that is you train something in a certain environment on a certain hardware, and then you push it to production, and it lives in a different environment on a different hardware, and it can just happen different things, and we need to make sure that nothing horrible happens.
Well, thank you very much, Martin. Before we wrap up and pose our third polling question, we may have time for one or two questions from attendees. But Bill, I know you wanted to talk about the future direction of artificial intelligence and machine learning in particular. So Bill, from Red Hat, I'd love to hear your perspective.
Oh, thank you so much, Joe. And I want to thank the PerceptiLabs team again for being here today. That was just tremendous, and really appreciate your time. And for us, the future of AI and ML, there are many folks can speak about it far more eloquently than I, but I do think one of the ways that we look at it right now is through the lens of biological systems. And there's a lot of talk about AI and ML as being reflections of human neurology. And so in looking at the enterprise, which is our area of focus, and from a practical perspective, we decided to apply some of those elements of biological structure to the enterprise itself. And so with a very close partner and good friend of ours, we began work along with PerceptiLabs and a few other select partners to come up with an AI neurosystem, something that is all pervasive within the context of an enterprise and reaches out into every element of the business and brings it back in to, I guess at this point again, that would basically help enable executive level decisions by load balancing all operations across a business, as disparate as the network, IT functions, logistics and supply and delivery, weather factors, facilities management, manufacturing. All those elements would be combined in a unified infrastructure from an open source domain perspective. And so I think you'll see more coming out in the coming months about that, and we're beginning that work in earnest right now. But we're really excited about it, and there are other ideas we're going to be bringing to the fore as well, because the infrastructure, strangely, is a very creative place, and it gives us the opportunity to do projects like that on really a very large scale. So we're really excited about that, and also working with our friends over at IBM Watson as well. I know that hasn't been mentioned yet, but I mean, we are part of IBM. We leverage their capabilities and their amazing consulting services, everything else across the board. And we also work with partners like PerceptiLabs as well, because we are a truly open source company. So that's all I had to say about that. Thank you.
Well, thank you very much, Bill. Before we wrap up, one thing I do want to do is pose our third polling question. Within what time frame, if any, does your organization intend to implement tools that support the ongoing development of machine learning models? Before we wrap up, I certainly want to thank our very distinguished guests, Bill and Václav of Red Hat, Martin and Robert of PerceptiLabs. Thank you so much. We thank attendees, of course. And I just want to point out that any questions we didn't have an opportunity to respond to from attendees, we will plan to follow up on post-event. I'm going to wrap up our poll here, but I do want to acknowledge kudos to those of you who are already looking to implement tools that support the ongoing development of machine learning models, and those of you who are planning to do so. If you'd like to learn more about Red Hat or PerceptiLabs, we invite you to visit their websites. Also, I've provided a link toward the bottom for more information about OpenShift in particular. Finally, I would point out that early bird tickets for our upcoming MLConf online event on November 6th are on sale now. Attendees of this webinar should mention RHW during registration for our MLConf online event on November 6th. If you do so, you can save an additional 15% on tickets. A link to registration page will be included in our next email. So once again, certainly want to thank all of you for joining. Want to thank our distinguished guests. Want to thank attendees. We look forward to your joining us at our next MLConf event. We thank you for your time, and we hope you enjoy the rest of your day.